Welcome back to the Data Science Blueprint Podcast. I'm Shanna, your host, and this is part 2 of our Mastering Data Science interview series. Today, we'll cover the remaining 45 questions, focusing on advanced machine learning topics such as decision trees, boosting algorithms, model deployment, and more. Whether you're preparing for a specific interview or simply leveling up your skills, this episode is your ultimate guide to tackling complex data science questions. Let's dive in and finish strong. Part 2, questions 46-90. Section 7, time series and forecasting. Question 46, what is a time series and how do you analyze it? Answer, a time series is a sequence of data points collected at successive, evenly spaced points in time. Analysis involves decomposition into trend, seasonality, and noise. And methods like ARIMA, autoregressive integrated moving average, are used for forecasting. Question 47, what is stationarity in time series? Answer, a time series is stationary if its statistical properties like mean, variance, and autocorrelation are constant over time. Stationarity is important because many time series forecasting methods, e.g. ARIMA, assume stationarity. Question 48, what are the main components of a time series? Answer, trend, the long-term increase or decrease in the data. Seasonality, recurring patterns at regular intervals, quarterly, yearly. Residuals, noise, random fluctuations in the data. Cyclic patterns, fluctuations with no fixed period. Question 49, what is ARIMA in time series forecasting? Answer, ARIMA, autoregressive integrated moving average, is a popular time series forecasting model. It combines autoregression, AR, differencing, I, and moving averages, MA, to capture trends, seasonality, and noise. ARIMA is best suited for univariate time series data that are non-stationary. Question 50, how do you check for stationarity in a time series? Answer, stationarity can be checked using visual inspection, plotting the time series, statistical tests, the augmented Dickey-Fuller ADF test, or Kwiatkowski-Phillips-Schmidt-Shin KPAS-S test are common methods to test for stationarity. Section 8, model deployment and maintenance. Question 51, how do you maintain a deployed machine learning model? Answer, 1, monitoring, continuously monitor the model's performance, e.g., accuracy, precision. 2, retraining, periodically retrain the model as new data becomes available. 3, evaluation, use metrics like F1 score and AUC-ROC to assess model performance. 4, model updates, deploy updated models to reflect new trends or data. Question 52, what is the significance of A/B testing in model evaluation? Answer, A/B testing is used to compare two models or system versions to evaluate which one performs better under specific conditions. In machine learning, it helps assess the real-world impact of model updates or changes on key business metrics like conversion rates or customer engagement. Question 53, what is model drift and how do you handle it? Answer, model drift occurs when the real-world data changes over time, leading to reduced model accuracy. It can be handled by monitoring metrics over time, retraining models with updated data, using adaptive learning techniques that adjust the model on the fly. Question 54, how do you handle model interpretability? Answer, model interpretability involves making machine learning models transparent and understandable to humans. Techniques include LIME, local interpretable model agnostic explanations, helps explain individual predictions. SHAP, Shapley additive explanations, assigns feature importance to predictions. Decision trees are naturally interpretable, while deep learning models may need these additional techniques. Section 9, statistical methods and techniques. Question 55, what is hypothesis testing? Answer, hypothesis testing is a statistical method used to make inferences about population parameters. It involves formulating a null hypothesis, HO, and an alternative hypothesis, H1, and using statistical tests, e.g. the t-test, ANOVA, to accept or reject the null hypothesis. Question 56. What is the p-value in hypothesis testing? Answer. The p-value measures the probability of obtaining results as extreme as the observed results, assuming the null hypothesis is true. A p-value below a threshold, e.g. 0.05, leads to rejecting the null hypothesis, indicating that the observed data is statistically significant. Question 57. What is confidence interval and how is it used? Answer. A confidence interval gives a range of values derived from sample data that is likely to contain the population parameter. For example, a 95% confidence interval means that if you repeat the experiment 100 times, the true parameter will fall within the interval 95 times. Question 58. What is the difference between type 1 and type 2 errors? Answer. Type 1 error, false positive, rejecting a true null hypothesis. Type 2 error, false negative, failing to reject a false null hypothesis. Balancing the two errors is crucial in hypothesis testing. Section 10, data processing and feature selection. Question 59. What is feature selection and why is it important? Answer. Feature selection is the process of selecting the most important features in the data set that contribute to the target variable. It reduces dimensionality, improves model interpretability, and decreases overfitting. Techniques include filter methods, e.g. chi-square tests, mutual information, wrapper methods, e.g. recursive feature elimination, embedded methods, e.g. lasso regression. Question 60. What are the different types of sampling techniques? Answer. Sampling techniques include 1. Random sampling. Each data point has an equal chance of selection. 2. Stratified sampling. Divides data into strata based on a feature, then samples from each stratum. 3. Cluster sampling. Samples entire clusters or groups. 4. Systematic sampling. Selects data at regular intervals. Question 61. How do you handle outliers in data? Answer. Remove outliers if they are erroneous. Transform the data using log or square root transformations. Impute values with domain-specific estimates. Use robust models like decision trees or random forests, which are less sensitive to outliers. Section 11, Advanced Machine Learning Techniques. Question 62. What is boosting and how does it work? Answer. Boosting is an ensemble technique that combines weak learners, typically decision trees, to create a strong model. It works by training models sequentially, where each model attempts to correct the errors of the previous one. Popular algorithms include AdaBoost and gradient boosting. Question 63. What is bagging and how does it differ from boosting? Answer. Bagging, bootstrap aggregating, involves training multiple models independently on different subsets of the data and averaging their predictions to improve accuracy. Unlike boosting, bagging focuses on reducing variance rather than correcting errors. Question 64. Explain the k-nearest neighbors KNN algorithm. Answer. KNN is a simple, non-parametric classification and regression algorithm. It classifies data points based on the majority class of their k nearest neighbors in feature space. For regression, it takes the average of the k nearest points. Question 65. What is a support vector machine, SVM? Answer. SVM is a supervised learning algorithm that finds the hyperplane that best separates different classes in feature space. It works well for both classification and regression, particularly in high-dimensional spaces. Section 12, Practical Application of Data Science. Question 66. How would you explain a data science project to a non-technical stakeholder? Answer. Focus on the problem the project solves and how the data-driven solution impacts business goals. Avoid technical jargon and emphasize the value, such as improved decision-making, reduced costs, or increased revenue with concrete examples of how insights were derived from data. Question 67. Have you ever dealt with unbalanced data sets? How did you address this issue? Answer, yes. Methods include oversampling the minority class, e.g. smoked, undersampling the majority class, using algorithms designed for imbalanced data like XGBoost or random forest. I also focus on metrics like precision, recall, and the F1 score rather than accuracy. Question 68. How do you determine if a feature is important in a model? Answer, techniques include feature importance from models, e.g. random forest, XGBoost, permutation importance, which measures the impact on model performance when a feature's values are randomly shuffled, correlation with target variable using statistical tests. 69. Describe Markov chains. A Markov chain is a stochastic process where the next state depends only on the current state and not on the sequence of events that preceded it. It is widely used in areas like natural language processing, game theory, and decision-making models. 70. Why is R used in data visualization? R is widely used for data visualization due to its comprehensive libraries like ggplot2, lattice, and plotly, which enable the creation of advanced customizable graphs. Additionally, R integrates well with statistical analysis, making it a favorite for exploratory data analysis. 71. What is the difference between a box plot and a histogram? Box plot summarizes data distribution through quartiles, showing the median, interquartile range, and outliers. Histogram displays the frequency distribution of a variable by dividing data into bins, showing how often values occur within a certain range. 72. What does NLP stand for? NLP stands for Natural Language Processing, a field of AI that focuses on enabling computers to understand, interpret, and generate human language. Examples include sentiment analysis, named entity recognition, and text classifications. 73. What is the difference between an error and a residual? Error, the difference between the actual and true value. Residual, the difference between the observed and predicted value by a model. 74. What is the difference between normalization and standardization? Normalization, rescaling data to a range between 0 and 1. Standardization, transforming data to have a mean of 0 and a standard deviation of 1. 75. What is the difference between point estimates and confidence intervals? Point estimate, a single value representing the best guess of a population parameter. Confidence interval, a range of values likely to contain the population parameter with a certain level of confidence. 76. Which is your favorite machine learning algorithm and why? One of the most versatile and widely favored algorithms is random forest because it combines multiple decision trees, provides high accuracy, and handles both classification and regression tasks while reducing overfitting through ensemble learning. 77. What is the most important skill in data science? A strong foundation in statistics is essential in data science. It helps in analyzing data, understanding distributions, applying statistical tests, and drawing meaningful insights from data. 78. Why is data science so popular today? Data science is popular due to the increasing availability of large data sets and the ability to derive valuable insights that drive decision-making across industries like healthcare, finance, and technology. 79. What is the most challenging data science project you've worked on? One of the most challenging projects involved text data processing, where unstructured text had to be cleaned and transformed using natural language processing techniques, followed by sentiment analysis, which required handling ambiguities in the data. 80. Do you prefer working on a project individually, in small teams, or in large teams? I enjoy both individual work for focused problem solving and collaborating in small teams where ideas can be shared and challenges tackled collectively for optimal outcomes. 81. What are your top predictions for the next 10 years in data science? 1. Widespread AI adoption in daily life. 2. Significant advancements in personalized healthcare using AI. 3. Automation transforming industries like manufacturing and logistics. 4. Stronger focus on AI ethics and regulation. 5. Quantum computing accelerating machine learning tasks. 82. What unique skills do you bring to a data science team? I bring a combination of technical expertise in machine learning, proficiency in data visualization, strong statistical knowledge, and the ability to translate complex results into actionable business insights. 83. How did you switch to data science and how did you upgrade your skills? I transitioned by upskilling through online courses focused on learning Python, SQL, and data visualization, and by working on personal and professional projects to apply my skills practically. 84. If given a random data set, how would you determine if it fits business needs? I would start with exploratory data analysis, EDA, to assess data quality and relevance, and align it with business objectives to ensure the data set contains the required features for decision making. 85. If you weren't a data scientist, what career would you choose? I would pursue a career in data engineering, which involves building the infrastructure necessary for collecting, storing, and processing large data sets that data scientists analyze. 86. How do you stay updated with constant changes in data science? I stay updated by participating in data science communities, attending webinars, reading industry blogs, and constantly taking online courses to sharpen my skills. 87. How do you resolve conflicts over different strategies in data projects? I resolve conflicts by encouraging open communication, ensuring all team members can voice their opinions, and finding a compromise or consensus based on the most data-driven approach. 88. Can you break down an algorithm you have used in a recent project? I recently worked with the random forest algorithm to build a predictive model for customer churn. It involved building multiple decision trees on random samples of the data and averaging their results to enhance model accuracy. 89. What tools did you use in your last project and why? For my last project, I used Python for data manipulation, Pandas for data analysis, scikit-learn for machine learning, and Tableau for data visualization. Each tool was chosen for its ease of use and efficiency in handling large data sets. 90. What is your preferred strategy for cleaning a large data set and why? I prefer an iterative approach to data cleaning, starting with missing value imputation, outlier detection, and feature scaling, followed by automation techniques to efficiently process large data sets in manageable steps. That concludes part 2 of our Mastering Data Science interview series on the Data Science Blueprint podcast. We've covered everything from decision trees to complex machine learning techniques. I hope these insights have armed you with the knowledge and confidence to excel in your next interview. If you enjoyed this episode, please subscribe and leave a review. It helps us reach more aspiring data scientists like you. Thanks for tuning in, and I wish you the best on your data science journey.